This is lesson 76 on pages 156 and 157. You need to copy the notes, and that way you'll have them when you get ready to do the classwork, and you don't have to refer back to the video. You can stop the video at any time, especially if I get ahead of you. Okay, lesson 76, volume of cylinders and cones. Now let's do a little bit of review and look back at the volume of prisms. And that is going to be on pages 149, it's lesson 72 and lesson 73. And we found out that the volume of any prism was going to be the area of the base times the height as we got ready to do it. And we did rectangular bases. We did, in number 2 on page 149, we did a hexagonal base, and we did a triangular base prism, because prisms, again, don't have to be sitting on their bases. In this case, the bases are the two congruent parallel polygons. And then when we did the volume of pyramids, we found that it took 3 of the pyramids to fill up the prism that would have the same base and height, and so we just simply took the volume of the prism and divided it by 3. Well, the same thing's going to work with cylinders and cones, and that's why we're going to actually do it in the same lesson. The volume of a cylinder is going to be, just like it was with the other, it's going to be the area of the base times its height. Well, think about it. A cylinder and a cone's base is going to be a circle. So the area of a base will always be pi r squared. And then the height of the prism, height of the cylinder. So let's do an example of a cylinder, and then we'll do an example of a cone. So there's your formula for volume of a cylinder, which is just a fancy name for a can. We don't have our geometers, but it's still pretty easy to draw them. I'm going to draw kind of a tall, skinny one, so you can just kind of make an oval. And if you want to make it a little more formal, you can dot the back of it. And then I just go up, and again, I don't have a straight edge handy with me, but I'm just going to freehand it. I'm going to go up to about 3 lines. And then I'm just going to draw the same thing. Now, in this case, you would draw the front and the back solid. So here's our bases. And so the volume is equal to the area of the base times the height. Now, we are going to use the pi key. Now, if you're at home and you have a calculator, if you're using your phone, or if you're using, now I think the calculator that some of you use on your device has the pi key on it. But if you don't have the pi key, and the answers are going to reflect it with the pi key. So I would recommend, instead of just typing 3.14, you could do 3.14159. You could use that if you don't have a calculator that doesn't have a pi key on it. So I've got my calculator handy. I'm just going to do it with the pi key. So in this case, we're given the diameter of the base is 6, if I can read the writing here, that is 6 meters. And then the height of the can is 8 meters. Okay, so we're going to first find the area of the base. Now remember, the area of base is pi r squared. Well, if the diameter is 6, then the radius would be half of that. So it's going to be pi times 3 squared. And then the height of the prism is 8. And I would type this. When we type it, we're going to actually just type it. I know we had the discussion about exact and rounded, but I'm going to actually do the pi times the 9 times the 8, and even, I can type it like that on my calculator, but I'm going to actually write it 72 pi, because that would be your exact answer. Remember, you're doing volume, so you're multiplying meters times meters times meters, which is going to be cubic meters. And then the approximate answer, and I believe the classwork is going to say round to hundreds, and hundreds is 2 decimal places. So if I type that on my calculator, I have 72. So you can see what I'm typing. Of course, I'm on the graphing calculator. That's what I brought home with me. Times pi is equal to 226. And notice that we've got a 6 here. Let's see, we're going to 2 decimal places, so the 4 here is going to make the 9 stay the same. So that is about 226.19 cubic meters. Okay. So, area of the base times the height, straightforward. There's your volume of your cylinder. I'll circle it, put a star by it. Well, then the volume of a cone is going to be the area of the base times the height divided by 3. Same setup as it was with prisms. Let's try one. Number 2. Now, cone's pretty easy to draw. You're just going to draw like a circular base. Let me straighten up my notebook there. And so I'm going to do kind of like I did up here. I'm going to draw a base. And then I'm going to dot the back. Now, estimate your center, and then take that height right up to just a height that you want. There's your apex up here. Then I'm going to make that solid. I'll make that solid. And it's not a bad cone. This is your height. It's perpendicular. And then this is your base. So in this case, we're going to let the radius, in this case, r equals, and I didn't put that up here. I should have said diameter equals the 6 meters. And so the radius is going to be, let's see if I find one I like. Let's do 2 inches. And then the height of the cone is going to be 5 inches. So volume equals area of the base. Let me see if I can adjust that notebook. I may can adjust the iPad probably better. Let me move it down just a little bit. Volume is equal to area of the base times the height divided by 3. So let's plug in what we know. We've got area of the base, circle. You got a circle with a radius of 2. So you got pi times 2 squared. I'm just plugging in. That's my area of my base. And then my height is 5. And then now if I stop there, that would be the volume of a can that is that tall. Like this picture up here, it would be a can. But because it is a cone, we're going to divide by 3. So now you can clean up. You can type it any way you want to on your calculator. You've got pi times, and if it's okay with you, I'm going to go ahead and do the 4 times the 5, which is 20, divided by 3. You can turn that around if you want to. I'm going to go ahead and type it. I'm going to type pi times 20. It is commutative, so you can actually type 20 times pi or pi times 20. So I'm going to do what I've got there, pi times 20, divided by 3. You can hit enter if you want to, and then divided by 3. And we're going to round to 2 decimal places. So we get 20.94. The 3 makes the 4 stay the same. So we get approximately 20.94. And then our units were inches times inches times inches, which is cubic inches.